right, here we go. We have something called periodic functions. Many phenomena are predictable because they are repetitive or cyclical. The water depths caused by the tides, the motion of a person on a swing, your height above the ground as you ride a Ferris wheel, and the number of hours of daylight each day throughout the year are all examples of cyclical patterns. In this half of our trig unit, you will discover how to model phenomena like these with the cosine and sine functions. Here's a real-world example. The water levels in the canals of Venice rise and fall periodically. During very high tides, the lower lying areas of Venice can be flooded. This phenomenon is called acqua alta, high water. It occurs more frequently when the moon is full or new, and when there are high winds. When output values of a function repeat at regular intervals, the function is called periodic. And one of the things I asked you to do on the intro activity is I said, how long on the x-axis did it take to repeat? We didn't talk about that. What was it? 360, right? It took 360 degrees. This is called the period of the function. So periodic functions have all the y values that are going to repeat over a certain length on the x-axis. That length on the x-axis is called the period of the function. It's the smallest horizontal distance it takes for the function to repeat. All trigonometric functions are periodic functions. Now that you sketched the graphs of sine and cosine using a very detailed table, we're going to try an easier approach, and it's called using the 5 main points. So before we make our table, I want you to sketch a teeny tiny little quadrantal unit circle. And we're going to assume we know the angles. 0, 90, 180, 270, 360. We're going to start today, tomorrow, and Wednesday graphing in degrees. Then Thursday, Friday, we're not going to do anything new except take all the angles and put them in radians. So we're going to go from 180 is pi, 360 is 2 pi, and so on. All right, so here's what I mean by the 5 main points. Well, what you learned from that little intro activity is sine and cosine both have a period length of 360 degrees. That's how long on the x-axis it takes until the cycle repeats. So here's what you're going to do, and I think this is going to help. I go 0 to 360. Halfway is 180. Half of 180 is 90. So that means I'm going by 90 degrees. It won't always go like this. As we start navigating and experimenting with transformations, we're going to see how this can change. All right, now I have y equals cosine x. On our little unit circle, how do you determine the cosine values around our circle? The x-coordinate, right? So what is the x-coordinate of cosine 0 degrees? 1. So guess what? In our table, at 0 degrees, we're going to put a 1. What is the cosine of 90 degrees then? Everybody.
0.
What's the cosine 180? Cosine 270?
0.
Cosine 360? All right, so here we go. So at 0 degrees, I'm going to go up to 1. 90 is 0. 180 is negative 1. 270 is 0. 360 is 1. You never have to memorize the table because I can just draw a circle and go right around and grab them. So the domain, now we just did one cycle, but it really does repeat. And it might be helpful if you, like it's going to turn here. And so you might put arrows going back down. What's my range then? Negative 1 to 1. So what's really neat is cosine as well as sine oscillate between -1 and +1. So do you remember earlier in our trig unit, and I asked you, could sine theta equal 3/2? And we said no, because the hypotenuse had to be the longer length, right? But now you can also see there's no way that sine theta or cosine theta can be 1.5. It doesn't hit there. It oscillates between -1 and 1. All right, we're going to use our same little circle. And we're going to use the same table because sine has a period length of 360 degrees. Now I'm going to pause and give you a head start. And I want you to look at your little circle and fill in the table for sine. And where do you find the sine coordinate? The y, exactly. Good job. If you're a fast worker, go ahead and plot them. Oh, and I love what I see as I'm walking around. These are nice rounded curves, okay? Make sure once in a while I'll have a student who makes them look like they're line segments. They're not, and one of the objectives of me having you after the quiz plot all those itty bitty points is so you can see how nice and rounded the curve is, okay? And then we're never ever gonna plot all those again, okay? We're gonna do the 5 main curves, or 5 main points. So this should have gone 0, 1, 0, -1, 0. Now, when you do enough of these, you might just begin to remember them, and that's a bonus. That's just a bonus. So here we go. This is 0, 90 degrees is 1, 180 is 0, 270 is -1, 360 is back to 0. So make it nice and rounded. If you wanted, now something I also notice, especially as we get into the transformations, you will end up making your own values on your x-axis. It doesn't always go 30-60, because sometimes I need a 45. So I might make my scale a little differently. What I like to do as I graph is I try to pay attention to what's the distance from one point to another on the x-axis. Do you see like it's 3 ticks, 3 ticks, 3 ticks, 3 ticks? Sometimes it's going to go 2 ticks, sometimes it's going to go 1 tick, sometimes it'll go 4 ticks, 5 ticks. It depends on what you make your x-axis, so it can vary. But then I know, let's just for funsies, so let's go 3 to the right and make an extra tick. Let's go 3 to the left and make an extra tick. Just so you can see, like, the pattern continues. So my domain for sine and cosine is always -infinity to infinity. The range, however, will vary. The range will vary depending on if I move it up and down, if I'm going to do some vertical stretches. So here's a big idea. Transformations of functions applies to trigonometric functions. So here's what I would like you to write down. If I write in general, and this would be true for cosine as well, but if I write y equals a sine b the quantity x minus h plus k, a is going to be a vertical dilation. The a value is your vertical dilation. It's going to be a stretch or a shrink. B is going to be a horizontal dilation. H is the left and the right. And your K is the up, down. And again, you knew this from functions, where we did absolute value of x, square root x, x squared, exponentials, logarithms. So I think this is about our 6th time through this year with transformations. So here we go. In example 3, it says determine the phase shift. Oh, I have to introduce a new word. A phase shift. Phase shift is another word for the left-right. In trigonometry, they use that because I think it's based in physics. Is there something like a phase in physics? Yeah, so that's my vague recollection of that, is that so in trigonometry, because trigonometry is used extensively in physics, math, we just say phase shift. So the phase shift would be, in this problem, left 30 degrees and up 1. So the phase shift is left 30, the vertical shift is up 1. Now the mapping notation. I'm going to show you the mapping, and eventually I'm going to show you a shortcut. And if you can handle the shortcut, you don't have to write the mapping notation. If you're like, I don't get the shortcut, then you can use the mapping notation. So I'm just trying to give you different tools, and you're going to figure out which tools you like better. So if I'm going to move left 30, that's going to take the x values minus 30. And if I'm going to move up 1, that's y plus 1. So this is just getting maybe the cobwebs out if we forgot about our mapping notation. So here's what I do. I start with my parent function, which in this case is going to be y equals cosine x. And here's the deal. You're going to inadvertently memorize these because we're going to write them so many times, and you're going to go, okay, now I know. Either you scroll up to your little circle, or you make another little circle, or I can do these in my head. I know to the right at 0 is 1 comma 0, so think of it in your head. Then cosine goes 1, and then I follow my pattern. So this parent table is going to go 1, 0, negative 1, 0, 1. So whether you can do it mentally, look up above, or sketch another circle. So now watch what we're going to do. We're going to now send it through the mapping notation. I'm going to subtract 30. So 0 minus 30 is negative 30. 90 minus 30 is 60. I'm going to pause a moment, and I want you to send all the x values through x minus 30 degrees and take all the y values and add 1. If you're a fast worker, start plotting them. Just to tell you about our week, we're going to spend all 5 days graphing sine and cosine. The first 3 days are going to be in degrees, the last 2 days in radians. Next Monday, we're going to review, and a week from Tuesday will be our final quiz. So this is it. Now, what's interesting about periodic functions is your starting y value should be your ending y value because it's cyclical. It's going to come back and then repeat. If you ever started at 2 and you're ending at 3, you made a mistake. Like there's something wrong. All right, so let's go negative 30 up 2. Now, be careful. This one is every 2 ticks. All right, 60 degrees is at 1. 150 is 0. 240 is 1. 330 is back up at 2. If you want to keep going, you can get a little more. So the domain of sine and cosine is always negative infinity to infinity. So far, we haven't done anything that's going to change the period length. We're going to learn about that tomorrow. What's my range? The range changed. 0 to 2. Now, I want to introduce a concept, and it's something called a midline. okay? A midline is going to be a horizontal line that cuts the y values in half. So if I'm up at 2 to 0, the midline is going to be this horizontal line going through y equals 1. The midline is always y equals the k value. The midline is always y equals the k value. All right, questions so far? Is it starting to connect? Like, is it's starting to click? Good, 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 good. All right, example 4. Go ahead and write down your transformations, your left, right, up, down. Try to come up with a mapping notation before I make my lap around the room to slow me down. And then I'm hoping you'll have a good 20 minutes to get started. And just trust me that when you first start graphing, these are going to take, it'll feel like a long time. And then once you get a little more comfortable, you get faster and faster at it. So today, the homework, I gave you 4 graphs. And I'm hoping you can get those 4 done in the 20 minutes. But it might take us a little longer as we're just learning this. All right, so this is right 60 degrees, down 2. So my mapping notation is going to be x plus 60 degrees, y minus 2. The phase shift is right 60. The vertical shift is down 2. Did we get that? Okay. So now, here's what you're going to do. You're going to end up making 2 tables. You're going to end up making 2 tables. You're going to do y equals sine x. And again, we don't know anything different than that the period length is 360 degrees. There's more to the story, but I'm trying to chunk this and build a decent foundation. So here's what I want you to do. Fill in from the little unit circle. If you have to draw a new one, mentally imagine it or scroll up to where we wrote them. Fill it in, then send it through the mapping notation to make a second table. If you're a fast worker, go ahead and plot them. All right, I'm going to start this. So sine starts at 0, 1, 0, negative 1, 0. I'm going to change colors for funsies. And if I add 60, here's my x column, and then I'm going to subtract 2. So here we go. At 60, I don't have enough space on here, right? So guess what? I'm going to take the liberty to go 1, 2, 3. Otherwise, you don't have enough space. And I think on homework, I left some of the axes. Either I made them go taller or I left them blank so you could change it to whatever you wanted. All right, so at 60, I'm at negative 2. At 150, I'm at negative 1. 240, I'm at negative 2. 330, I'm at negative 3. And then 420, I'm back at negative 2. If you want to continue it a little bit, it's going to go like this. So the domain is negative infinity to infinity. What's my range?
-3 to -1.
Good job. -3 to -1.